Hello everyone, welcome to Equal to. So this is the 8th video of our Polynomials playlist and I hope you watched the past 7 videos. If you haven't, please go and check them out before watching this one. And in this video, we are going to be solving the last question of exercise 2.2. Okay, so in the previous video, we have solved the third question, right? And the video before that, we have been solving first and second question. So with continuing that, I hope we already know the concepts that are required to solve this question. So we have to know that what is the zero of a polynomial? A zero of a polynomial is a value that on substituted into the polynomial, the value of the entire polynomial becomes zero. Okay, so that is the definition. We have seen this from so many videos. Like in the previous video, the video before that, we know what a zero of the polynomial is. Okay, so how to find the zero of the polynomial? In this video, this question particularly, let me just read the question first. Find the zero of a polynomial in each of the following cases. Okay, so we have 7 subdivisions, I guess. Okay, all these 7 subdivisions, you are going to find the zero of the polynomial. Okay, so essentially a value that on substituting for x would give 0 for x plus 5. Okay, so that is what we are going to find. So the concept is very simple. So what you're going to do is you need to know, so p of x should be equal to 0. Okay, only when p of x equal to 0, in that case the value of x that you get, that is the zero of the polynomial, or you can say a solution of the polynomial, right? So that is what you are going to do. So you are going to find the value for which p of x equal to 0. So that is exactly what we will do. X plus 5 is equal to 0 because we want that to equal to 0, right? So what would be the value of x? We are subtracting 5 from each side, so minus 5 and minus 5, so that gives you x equals minus 5. Or in simpler terms, you can tell you are taking the 5 to the other side, but that technically is not right. You are just subtracting 5 on both sides, right? So if x plus 5 equals 0, then x equals minus 5, and minus 5 is a zero of this polynomial. Minus 5 is a zero of x plus 5. Okay, so this is basically a linear equation, and on equating that to 0, you get x plus 5, x equals minus 5. So the degree of this polynomial is 1, right? So the degree is 1, meaning it will have only one solution, and that one solution is minus 5. Okay, so moving on to the next subdivision here, p of x equal to x minus 5. Again, we are just going to equate p of x to 0. P of x equals 0, so that implies x minus 5 equals 0, and adding 5 on both sides gets you x equals 5. Okay, or you can other one say you are bringing 5 to the other side, that becomes positive 5. So x equals 5, and that is the answer to this question. So 5 is a zero of x minus 5. So the procedure is quite simple. You are just going to equate p of x equal to 0, and with that you are going to try to solve for x. Okay, so that is all the procedure is, and you are just going to simply repeat that procedure for the next question as well. Okay, so p of x equals 2x plus 5. So p of x equals 0, so 2x plus 5 equals 0. You're subtracting 5 on both sides, that gives you 2x equal to minus 5, and you're dividing by 2 on both sides, that gives you x equal to minus 5 by 2. Okay, so x equal to minus 5 by 2 is a 0 to this polynomial. Minus 5 by 2 is a 0 of 2x plus 5. Okay, so moving on to the next subdivision. These are very simple questions. You can just try to follow along, or you can just also try to solve along with a notebook and pen and a paper. Okay, so again the same procedure. You are going to equate p of x to 0, so p of x equals 0, and 3x minus 2 is equal to 0. So adding 2 on both sides gets you 3x equals 2, and dividing by 3 on both sides gives you x equal to 2 by 3. Again, this is also a linear equation, so only one solution here. So 2 by 3 is a 0 of 3x minus 2. Okay, moving on to the next subdivision. So we are just flying through these, this is very simple, right? There is no complicated concept here. You're just equating p of x equal to 0 and you're finding the value of x. You just have to know what the definition of 0 is or what 0 actually means for an equation. So again, p of x equals 0, so 3x equals 0. Okay, so now we have only two products and that multiplies to 0. The product of these two numbers gives you 0. So what that means is, if any one of these numbers is 0, only then the product can be 0. So let us say if a into b equal to 0, any one of these numbers can be 0, so that will lead to 0, right? So if a into 0 is also 0 and 0 into b is also 0. So for the answer to be 0, either one of these numbers being 0 is more than enough, right? So what you can do is, you can say either 3 equal to 0 or x equal to 0. 3, as we know for sure, is not equal to 0 because 3 is a number, right? 3 is a number and it has value 3. That is not equal to 0. So obviously x is equal to 0 and 0 is a 0 of 3x. This statement is quite ironic. 0 is a 0 of 3x. Okay, so I hope you got this concept, right? If a product of two numbers is 0, one of that numbers should be 0. Okay, in this case 3 most definitely is not 0, so x has to be 0 in order for 3x to be 0. Okay, moving on to the next subdivision. This also is similar to the previous question. So p of x is equal to 0, so that means ax is equal to 0. So you can say either a can be 0, a can be, sorry, not cab, a can be 0 or x can be 0. Okay, similar to the previous question, but in the question they have given that a is clearly not equal to 0. Okay, so in that case you can avoid this case, right? A cannot be 0 in this case, so x has to be 0. Because a is not equal to 0. Okay, a is a constant. Okay, so and that they are saying is not equal to 0, so x has to be 0 for ax equal to 0. So 0 is a, again, why am I doing the same mistake? 0 is a 0 of ax. This is very similar to the previous subdivision, right? These are very similar questions. Okay, in this case we knew that 3 of course is not equal to 0. We knew that as a fact, and in this case in the question itself they are given that a is simply not equal to 0. Now moving on to the 7th subdivision here, and this is going to be the last subdivision of this question, and with that we will be coming to an end as well. So again the same procedure repeats. So p of x is equal to 0, so that means cx plus d is going to be equal to 0. So cx is equal to minus d and x is equal to minus d divided by c. Okay, so x is equal to minus d divided by c. So we are subtracting d on both sides and we are dividing by c on both sides. So that gives you x equal to minus d by c, and we have been given that c is not equal to 0. Why is that relevant in this case? C is not equal to 0 because if you are dividing a number by 0, that gives you an undefined number. Okay, so that is not preferable. So they have given that c clearly is not equal to 0 and c and d are real numbers. Okay, so minus d by c is a 0 of cx plus d. Okay, so that is the answer to this question, answer to the subdivision. So we have solved 7 subdivisions in this question, which is the 4th question of the exercise 2.2. I hope you understood this. If you have any questions, please feel free to put them in the comments. I'll get back to you as soon as possible. Thank you so much for watching this video. In the next video, we'll be starting the next section and starting with the example questions. So stay tuned for that. Consider subscribing to Equal to. See you in the next video. Bye for now.